I've had the privilege of studying high-performing technology organizations since 1999. And so that journey for me started when I was a CTO and founder of a company called Tripwire, which I originally wrote back when I was a student of Dr. Gene Spafford at Purdue University in 1991. And so these high performers were those organizations that had the best project due date performance in development, the best operational availability and stability, the best security, and the best compliance. And so our goal was really to understand what were these organizations doing differently that allowed them to make their good to great transformation. So that, and why did we want to know that? So that other organizations, the rest of us, could actually replicate those transformations. And so trust me, there were many surprises on that journey. And perhaps the biggest one was that it took me straight into the heart of the DevOps movement, which I think is urgent and important because it solves the most pressing business problem of our generation, the likes of which we haven't seen in 30 years when manufacturing was transformed in the 1980s through the lean principles. So as your self-appointed ambassador from the DevOps community, I really want to share with you two things. One is the why of DevOps, why do I think it's urgent and important, and two are the how. What are the patterns we're observing that you can see in the dev, test, ops, information security value stream that's allowing organizations to do hundreds, thousands, or tens of thousands of deployments per day while preserving world-class availability, reliability, and stability. And this is special to me because I think when the kernel of that DevOps community really started in this community, right? How do I know that? Because I used to read all the proceedings that came out of the LISA journals 15 years ago, and before that I read all the login newsletters because the editor was Dr. Rob Kolstad, who was the person who actually hired me into Sun Microsystems in 1986. So I've read all of Mark Burgess's CF Engine work, and I think you're going to see that weaved into everything that we do inside of DevOps. So just to share with you the why of DevOps. It's because we started around 2006, we started noticing that there was a downward spiral that happens in every IT organization, regardless of industry vertical, regardless of company size, profit, not for profit, and left unchecked without something like DevOps, horrendous things would happen. Not just in dev, test, and ops, but ultimately the organizations we serve. So let me just share with you what that downward spiral looks like. And the Act 1 always begins in operations, right? And so this is Lisa, right? We're ops people. So I think for those of, if a developer accidentally wandered in here, right, what we would want to convey to them is that the bane of our existence in operations is fragile artifacts, right? Whether it's fragile code or fragile infrastructure. And why do we call it fragile? It's because every time we touch it or even look at it wrong, it falls over, causes an unplanned outage, or a catastrophic amount of unplanned work. The tragedy is that when you ask where do the most fragile artifacts live, almost invariably it's in one of two places. It's either in the most critical business operations, the largest revenue generator for the organization, which we all depend upon in order to achieve our goals, or it's in the most critical project, that thing that we must complete in order to catch up with the competition because they've been doing it for years. And so when you find fragile code or fragile environments inside of those two places, something terrible occurs, which is that the organization ceases to become able to meet the promises it makes to the outside world. So sometimes that's features that we promise to customers. Sometimes it's the revenue commitments that we make. Sometimes it's the earnings per share promises that we make to Wall Street. Or maybe it's showing the analysts that we have not only a viable strategy, but that we can actually execute. And so speaking as a married person who's now been married for almost 10 years, I can say with some authority that when we break promises to someone else, we tend to overcompensate by making even larger, more audacious promises that we have an even less likelihood of being able to hit, right? And so I think that's part of human nature. We do that in our interpersonal relationships, but I think organizations do that as well. So the problem is not that. That's part of human nature. The problem is who is making those promises. And it's often these people, the product managers in marketing, the art majors, creative writing majors, and let me state for the record, some of my best friends are creative writing majors. The problem is they may not know, what technology can or can't do, right? The problem is the commitment has been made, a date has been set, and now we set the stage for Act 2, which are the developers. And just to, by the way, my formal training was as a developer. But I think one of my favorite jokes that I've heard in operations is I heard 10 years ago when I was in Detroit, someone said, guess which week we had the fewest number of 7-1 outages on record? It was during Oracle World, right? Why? Because all our DBAs were at Moscone Center, right, being trained in the latest tips and tricks. I'm like, that is hilarious, right? He said, no, that's not the funny part. The funny part is, guess which week we had the highest number of 7-1 incidents? The week they came back, right? Why? Because they were taking everything they had learned and putting it into production without testing it first, right? Very, very funny, right? But so whether we're talking about the devs or the DBAs, what we see from a development community is that every time a commitment is made to the outside world in terms of a feature, we now see an urgent, date-driven project that must complete whatever it takes. And so that means cutting corners, that means cutting features. But long before we cut features, we tend to cut other things, right? The non-functional requirements, operability, maintainability, deployability, all those non-functional requirements, security, capacity testing, right? All these things that we need in order to actually run predictably and provide reliable service to the customer. And so when that happens, we start to accrue what Ward Cunningham called technical debt. And, so this was 15 years ago, comes from the dev community, and I think it's just a marvelous phrase because it evokes, in my mind, this image. Technical debt, every time we cut the non-functional requirements, leads to one more fragile artifact in production that's fragile, that causes more firefighting in operations. But technical debt is like financial debt, right? It grows worse over time. So this, although bad, is not as bad as this, right? So, and imagine how bad this is for availability, right? We have a site-wide outage. We even, we have amazing configuration management practices, so we even know it's due to a cabling error between the SAN and the database. The question becomes, which cable is it? The answer is obviously this one, right? The problem is, be careful which cable you touch because we know there's a loose cable in there somewhere, right? And if you touch the wrong one, the entire site will go down like last week, but we'll fix it when we have a little bit more time. And that's the insidious nature of technical debt, right? We never fix it, and technical debt accrues decade over decade. So as bad as that downward spiral is, there's actually a more insidious downward spiral that happens that is far more corrosive, which is that deployments start taking longer, right? So think of a friend who wrote an application that used to take 5 days to deploy, starts taking a day, starts taking a weekend, starts taking a week. It doesn't end there, right? I've had firsthand experience of a $6 billion a year revenue business. Their deploys took 6 weeks to perform. This involves 1,300 manual, discrete, very error-prone steps, right? That would tie up something like 300 to 400 people within ops and test, and sometimes even developers. And so when that happens, I think this is what really creates a kernel of the intra-tribal warfare that exists between dev, test, and ops, right? So here's our friendly developer, checking in code into the source code repo on Friday. They high-five each other in the parking lot, start buying each other shots at the bar, not realizing that they set the entire data center on fire for the entire weekend, right? And then now we have to bring the devs in at 2 a.m., right, after they've been drinking, right? Now you have angry dev and ops. That's not good. So at this point, the real point of this is at this stage, no one is winning, right? Features aren't getting to market quickly. Deployments are taking longer. We have an ever-increasing number of 7 outages in production. And operations becomes mired in technical debt and unplanned work, increasingly unable to pay down technical debt to help our organizations actually win in the marketplace. Does anyone have a friend that can resonate with some elements of the story? Okay. That's our life, right? So the answer is, so why is this important? It's because these are the conditions which create hopelessness and despair. Right? Sense of being trapped in a never-ending horror movie where we feel powerless to change the outcomes, and we are trapped in a system that preordains failure. A friend of mine, his name is Josh Corman, he did a study of burnout in information security, and I think the answers are, the findings were startling, and I think is as applicable to operations as well. He found that the rates of burnout in security were off the charts. It was higher than first responders, higher than physicians in the ER, higher than people doing multiple tours of duty in the military, right? What are the signs of burnout? There are 3 primary ones. First is fatigue. Second is cynicism. And the third one is illusions of self-efficacy. We actually think that we're better than we are, right? The hero complex, right? So I think, so what do information security and ops have in common? We are both stuck downstream of people creating problems upstream development, right? So it doesn't have to be this way. And why is that important? Because what I've learned in my journey is there's no worse thing that we can do to a fellow human being than to put them into a situation where they can't control their own outcomes, right? And so what makes, so why is this downward spiral important? Because this happens everywhere. Independent of industry vertical, independent of company size, profit, not for profit, right? Left unchecked without something like DevOps, these outcomes are almost preordained. So Act 3 is, that there is a better way, right? And we saw this in the very beginning of the LISA papers written 15 years ago. But these things are now under a whole umbrella of practices that we're calling DevOps. And so why do we know that there's a better way? Because organizations like Google, Amazon, Netflix, these unicorns are showing that you can break this core chronic conflict. You can actually have high throughput of planned changes from dev through test into operations while preserving world-class reliability, availability, and stability. And it's not just the unicorns, right? It's everybody that can put these into practices. So in my mind, I have a sense of certainty that when historians look back 10 years from now, they're going to say something fundamentally transformative happened around this time. That how we work with technology changed, and just like the Cambrian explosion, there's a distinct before and after. And so I think DevOps is going to be the primary narrative in that. So continuous delivery will be certainly a part, Agile will be a part, but I think it's going to be DevOps that's actually be pointed at as a dominant part of why this transformation happened. And when they ask where did DevOps come from, they'll of course point to this presentation that was given by John Alspaugh and Paul Hammond at the Velocity conference. And so the famous 10 deploys a day at Flickr. And so by all first-hand accounts, people who were there, how many people were here for that presentation? So for those of who, when you ask people who were there at that presentation, they will say they knew in that moment that they were in the presence of something historically significant. But I say with some embarrassment, that was not my reaction. Right? My reaction was more like this. It's like 10 deploys a day. One, that's impossible, right? They're lying. Right? And if it's not lying, it's probably immoral, reckless, ill-advised, and mean. Because what sort of bad person would want to do 10 deploys a day to someone else, right? It's just not done. And yet I now believe that, whether we're in dev, test, or ops, if we can't create around us a system of work that actually can sustain multiple deploys a day, or maybe more specifically, deploys on demand, then we risk irrelevance. And certainly the organization that we serve risk of irrelevance. And so, the beautiful parts of what was shared in the Alspaugh-Hammond presentation was just saying how different dev and ops are. They said they are archetypally diametric poles. Dev is embodied by Spock. Spock gets to sit on the bridge with Captain Kirk. Captain Kirk actually asks him questions, listens to his advice, gives him budget and positional power, whereas ops is best embodied by Scotty, who doesn't get to sit on the bridge. He's stuck in the basement. The only meetings that he gets invited to are the Sev 1 outage calls when the warp engines are down. And what's amazing is that when the warp engines are down, Scotty doesn't say, you've deferred planned maintenance for 5 years, you fix it. It's not my problem. And yet, even though he saves the day, he doesn't get to sit on the bridge with Captain Kirk. Doesn't get the same positional and budgetary authority as Spock. And I think that, seems wrong. And by the way, as information security, who are we? We're these guys. Whenever there's a repeat audit finding going to the 3rd year, right? It's obviously a security issue, and we'll take care of that. And what I love about the DevOps community is it is one fundamentally of boundary spanning. So Theo Schlossnagel, who is here, I think evokes this most beautifully. He said, he hates the term DevOps, right? Even though we want dev people who think like ops and vice versa, he thinks it is a terrible term. In his mind, it's incomplete, it's prone to misinterpretation. What would he want to call it? In his mind, at Velocity 2010, he said he wants to call it star ops, or maybe more pedantically, dot star ops, or maybe more pedantically, every department ops. And I think, the real question that he was asking was, where's network engineering? Where's information security? Where's reliability engineering? And where's product owners? Because essentially what he was saying was that you need that entire village to be mobilized in order to achieve these amazing outcomes of being able to have high throughput and high reliability, something that we knew for decades it was very, very difficult to do. So one of the things that I treasure most in my journey is working with the Software Engineering Institute at Carnegie Mellon University. And I learned many things from them. But one of the things I think about a lot is this one phrase: high performers in every field accelerate away from the herd. And that's absolutely happening in the DevOps space. In 2009, just 5 years ago, we thought 10 deploys a day was shockingly fast. And these days it's considered, average, maybe even mediocre. And just as a data point for this, John Jenkins at Amazon at the Velocity 2011 conference said they're not doing 10 deploys a day. They're doing 1 deploy every 11.4 seconds. So that's a mean number of deployments per day of about 23,000. So what's a deploy? It could be, a code push into production in a disabled state hidden behind a feature flag. It could be a release of a feature behind an A/B test. It could be a configuration change in the environment. It could be, 10,000 new environments going online, all considered to be 1 deploy. So why is this important? Because what this demonstrates is that we can make changes when our organizations need it most. And for me, the most, the quote that really put this into focus for me came from Scott Cook. He's the founder of Intuit. And he said, for their TurboTax property, they did 165 production experiments during the peak tax filing season. And so when I first read this quote, as you can imagine, my first reaction was, these guys are morons, right? What sort of idiot would make changes, during peak traffic season? Because the way I was trained, especially in retailing, we were so afraid of the holiday outage that we had a change freeze from October 1 to January 30th, right? And so why would these idiots, allow changes when we need uptime the most? And the answer is revealed in this next paragraph. He said, by enabling these experiments, we were able to increase the conversion of the website by 50%. So there are three, I think, kind of aha moments I had. One was it takes great dev and ops, kung fu, and collaboration to enable this. Two is that maybe the best time to do production experiments and production changes is during peak traffic seasons. In other words, what would have happened if they had waited until April 16th when the tax filing season was over? Right? They could have potentially lost their prospects and customers to the competition, never again to return. And then third is, I think this is one of the key capabilities that allows our organizations to win in the marketplace. In other words, there's a growing school of thought that says to win in the marketplace requires us to out-experiment the competition. Not every idea is a good idea. On average, it's about 1 out of 10 that are actually exothermic, right? So the question becomes, which idea is it, right? And it's only through relentless testing, that we can actually find out which one. As Leonard Cohen, the singer-songwriter, said, if he knew where the good songs came from, he would go there more often, right? In the absence of that, right, it's only through testing and experimentation that we can do that. So I think this explains why, so many organizations are adopting DevOps. It's not just the unicorns, it's also the horses. It's financial services, it's our suppliers, it's retailers, it's manufacturers. By the way, Raytheon gave a talk about how they're doing continuous integration and DevOps for the ground control stations that control satellites. Government agencies like the US Department of Homeland Security, higher education. So the question is why? Why would organizations that are not traditionally known to adopt very radical practices like DevOps, which I believe is actually considered a radical practice, why would they be adopting DevOps when they are not known to be early adopters? And I think the reason is that the business value and organizational value of adopting DevOps is even higher than we thought. And so one of the funnest projects I've had the privilege of working on is actually over the last 3 years working with Jez Humble, who wrote the Continuous Delivery book, and working with Dr. Nicole, where we benchmarked 14,000 organizations over the last 2 years to figure out what does high performance look like and what predicts performance. So let me share with you what those top 3 surprises are. The top surprise is really high performers are massively outperforming their non-high performing peers. We know this because they're doing 30 times more frequent deployments being a code deployment or an environment deployment, and they can complete them 8,000 times faster. In other words, how quickly can they go from code committed by development or ops through the test cycle, through the deployment cycle, actually running in production? High performance can do it in minutes, whereas lower performance take months or quarters, right? So that's 4 orders of magnitude difference. So not only are they doing more work, right? Not only do they have higher throughput, but they're getting far better outcomes. When they do a deploy, they are twice as likely to succeed without causing a service impairment, have one outage, security or compliance failure. And when something does, bad happen, they can fix it 12 times faster. The mean time to repair service is 12 times faster. And so in my mind, this is such an important finding because it gave us empirical evidence that you can actually go, have higher throughput and have higher reliability at the same time, right? And by the way, it turns out that if you want reliability profiles that look like this, you have to do smaller deployments more frequently, and I'll share with you some more data on that. But there's an even bigger shock that came out of this year's study, after benchmarking 9,600 organizations, or as Nicole would probably say more pedantically, 9,600 respondents. We found that high performers, not only do they have better IT performance, change success rate, mean time to prepare, deployment frequency, lead time, they had better organizational performance, as measured by they were twice as likely to exceed profitability, market share, and productivity goals. And for those 1,300-ish organizations that actually put in a stock ticker symbol, we found that the high performers had 50% higher market cap growth over 3 years compared to the low performers. Isn't that amazing? By the way, how am I doing here? Is this interesting? Right? All right, so thank you, Nicole. Right, this is this was a very important finding because it says it's not just DevOps is not just good for dev, test, and ops. It's also good for the organizations that we serve. So the other data point I want to give to you before we go into the how is this one. When Jez Hummel and I found these guys, this was so exciting to us. There's a guy named Darren Haig. He's an operations architect at SAP. And he gave a presentation at Java 1 2 years ago that said that by implementing DevOps, he was able to reduce the lead time from code committed to running in production from 9 months to a week. Right? And by the way, their remit is to deliver SAP service internally within SAP and externally to the customer. And so our reaction, I would submit to you this. If you can do it for SAP, you can do it for anything, right? Because I can't imagine a piece of software more designed not to be agile than SAP. Well, in fact, and now we actually have data points saying that we can do it for COBOL mainframe apps, right? So if we can do it for COBOL mainframe apps, SAP, HP, LaserJet firmware, as enterprise practitioners, I think we were running out of excuses not to tackle the most hairy, awful systems and be able to put some of these patterns and practices in place. So if there's one book I would recommend to everybody, it's a book called The Goal by Dr. Eliyahu Goldratt. It was written in the 1980s. It was credited for changing how an entire generation of managers thought about plant operations. And so it's a novel about a plant manager who has to fix his cost and due date issues in 90 days, otherwise they shut the plant down. And so there was no doubt in my mind when I read this book that those lessons being imparted in that book were relevant to the work that we do every day. And so for over a decade, we wanted to write the Phoenix Project, which is essentially the goal for IT. And so there are many similarities between the goal and the Phoenix Project, and that's by design. For over a decade, we studied that book, getting ready to write the Phoenix Project. But one of the similarities is they both have a Yoda, Mr. Miyagi-like character who speaks in very kind of hard to understand ways. And so our Yoda speaks in the language of the 3 ways. And what the 3 ways are intended to be are the set of principles from which you can derive all of the observed DevOps patterns from. So in the next 40 minutes, what I want to do is share with you what those 3 ways are, the principles, and then all the patterns that we can observe that hopefully has some practical value to you as well. So the first way is all about flow as we go from left to right in the value stream, from dev to ops. And by the way, this begs the question, why dev and ops? It's because dev and ops are what's in between the organizations that we serve and our customers, right? Whenever requirements turn into engineering requirements that must then successfully transition to service to actually create value for the customer, right? That goes through the DevOps value stream. And so in the DevOps community, I think without a doubt, our favorite metric is deploys per day. We know that Flickr did 10 deploys a day, Etsy does 600, Amazon does 23,000. But in the manufacturing world, their cherished metric is obviously not deploys per day, it's lead time. So in their world, lead time is measured by how quickly can we go from raw materials at one end of the plant to finished goods at the other, right? And there's been a decades-long belief that lead time is the most accurate predictor of quality, customer satisfaction, and employee happiness. And what we found in the benchmarking as well is that apparently is true in the DevOps space as well. So what is lead time? I think in the big value stream, it's probably when dev accepts work, to actually work on it, implements, goes into the source code repo, goes through test ops, the deployment pipeline actually runs in production. But I think for the vast majority of organizations, we can actually look at a subset of that, which is, how quickly can we go from code committed through test, through deployment, running in service successfully. And lead time, as I mentioned, is a great predictor of many things. It's also a great predictor of this. The relative, in D&D, is it like the elves and humans, or is it like the elves and dwarves, right? Like how much do they not like each other? What's the level of cultural distrust? But lead time is also a great predictor of this. Catastrophic deployment outcomes, right? So, in my mind, if you think about the worst catastrophic kind of deployment errors over the last, actually not deployment errors, just errors in the last 20 years, Toys R Us, 1999, Amazon, 2001, LinkedIn, 2008, healthcare.gov maybe probably belongs up there. Regardless of what your politics are, what we found is that whenever there's very, long lead times tend to be very correlated with those accidents. And I think one of the primary contributing factors is that the first time when the code was actually running in a production-like environment was during the deployment. Right, does that resonate with you? In other words, the first time when the code is actually running in anything remotely resembling production was during the deploy. So if you believe that, then the countermeasure really becomes something that we've observed every high performer doing, which is that operations makes available environments available on demand, right? You don't have to open up a ticket. You don't have to wait 28 weeks, right? Anyone who wants one can get one. Where do they come from? They come from an automated build process, whether it's Puppet Chef, CF Engine, Ansible, whatever, right? Docker, VMware, right-click. It means that whoever wants one can get one, completely self-service. Incidentally, where do those environments come from? They come from a common build mechanism that builds a dev, test, and production environments all at the same time. And I think the constituency, when operations can make that available, the constituency who gets the most value fastest beyond the customer is development. And the reason is that it means that we can now have developers running their code in production-like environments in the earliest stages of the development process. And so, by the way, I love this, the definition of done from the Scrum toolkit. The notion is you have to have short development intervals, and at the end of each sprint or development interval, you have to have working and potentially shippable code. But I wish I could go back in time 10 years and just have them add one more phrase, right? Because we know that's good and necessary, but not sufficient. We need to add just one more phrase. At the end of each sprint, dev has to have working and shippable code demonstrated in an environment that matches production, right? And so, just a small sort of change, creates incredibly amazing improvements in outcomes. Why? Because that means at the end of even the first sprint, the team is actually forced to integrate not only the code branches with each other, but they are now integrating the code in a production-like environment. And so that means by the end of the project, that integration has been performed hundreds or maybe even thousands of times. And by the way, just to share with you maybe how much of a surprise this was for me, I used to think that developers hated testing their code, right? And it's not because I, don't like developers. Some of my best friends are developers. However, it was the only plausible explanation that could explain what does the things I've seen deployed into production, right? If you've seen what I've seen deployed into production, the only conclusion is they clearly don't like testing the code. But here's an alternate causation. Maybe they want to test their code, but they can't wait 50 weeks to get an environment, right? And so the only place where they want to test their code so much, they go to that guy or that person, right, who has a reputation of being able to find one. But you just never want to ask, where did it come from? Because you know that somewhere, someone is missing their server, right? It's also probably about 2 years old, which actually negates a lot of the testing objectives. Let's see here. So how awesome, so I think in my mind, one of the best examples of these practices at play is the Facebook chat story. And it was actually Jez Humble who sort of forced me to reevaluate this and understand its true significance. My first reaction was like, this is not important because it's a chat server. I wrote one as an undergraduate, not so hard. But apparently with 90 million users, yeah, very hard. Order n cubed is, I think it is, right, the naive implementation. So it was actually one of the largest technical undertakings that Facebook had undertaken. It was one of the largest project teams. It was one of the first use of Erlang on the back end. It took 1 year to complete. And so how did they use that year? Every day, the developers were checking code into trunk, and whatever's in trunk would eventually get into production that same day. And moreover, they were using every active browser session as a test harness. They would actually send invisible test messages to the backend servers for almost a year. So when it actually came time to announce the availability of Facebook chat, they went from 0 users to 78 million users overnight without a hitch. How? They were testing in production for almost a year. So, yeah, if I could replay that, they're testing in production in a year. I thought testing in production is what bad developers did who hated ops people, right? But it turns out, that's a total game changer because it allows us to do things like this. And so what are the specific practices that enable that? They're decoupling the feature release from the code or environment deploy. In my mind, the best metaphor for this is Operation Desert Shield. That was about a 1-year-long project where every day they staged thousands of men and materials into a staging environment. And there was one marketing release event, which was the transition to Operation Desert Storm, right? So our goal as engineers, whether we're in dev, test, or ops, is to make sure that every day we can actually promote code and environment changes safely into production as a part of our normal daily work. And we can now hold marketing responsible for, did it achieve the desired outcome? Was it worth our time? And when we conflate deployment risk and release risk, all sorts of bad things happen. So this means that we have to be able to deploy code and have it safely hidden from the customer. It means that developers have to check in code into trunk, and whatever gets into trunk must make it into production, as opposed to developers hanging on to private code branches and integrating only at the end, which makes life even harder for ops. And what this does is it frees ourselves from this learned behavior that deployments hurt. And it means that no longer do we have to do deployments only at midnight on Friday, right, and work all weekend to get it running, right? Now we can actually do deployments in the middle of the day seamlessly and have the work hours of ops synchronized with development like normal human beings. And I think that's important. By the way, lest you think that this is only for Google, Amazon, Netflix, Etsy, and so forth. This is only for open source software. I would submit to you this graph. This came from Scott Prue from CSG. They're the largest bill printing company in the US. And so he described an experiment that he did with the COBOL mainframe app and the surrounding 20 technology platforms, right? So it is like a mammoth, 21 cluster deployment effort. And so the experiment was this. They halved the deployment interval from once every 28 weeks to once every 14 weeks, right? And what were the results? Incident rate went down by 60%. Mean time to repair went down by 80%. And what they call the settlement time. How long was required to actually have the application run in a hands-off state? It went from 14 days to 1 day. So I told Scott, that is the most amazing statistic. Thank you so much. He's like, well, Gene, you actually missed the point. It's not only is it good for dev, test, and ops, the real value is this. The customer got the value in half the time. Right? So not only is it good for dev, test, and ops, it's even better for the customers that we serve. Can I just do a little temperature check? Is this interesting? Can you give me a thumbs up? Okay, all right. Awesome. Phew. So I think this is important. And it was, I think the best manifestation of this, I would give to you something that Nathan Shimmick told me at FlowCon 2 months ago. He said, thanks for the Phoenix project, whatever. He said, because, and I asked him why. He said, as a lifelong ops practitioner, I know that we need DevOps to make our work humane. He said, in my career, I have worked on every holiday, on my birthday, on my spouse's birthday, and even on the day my son was born. So when I heard this, I actually had tears come to my eyes, right? Because I think having done, having friends in ops, I think we can all share elements of the story, right? So, it doesn't have to be this way, and I think DevOps really does make our work humane. So, as ops people, right, I think we're surrounded by people who are afraid of DevOps because they think that it's going to automate everyone's job away, right? I would submit to you there's actually a bigger harm that's being done, right, as evidenced by Nathan Shimmick. Let me just share with you kind of what transformations look like as we go from lead time measured in months to lead time measured in minutes. One of my favorite quotes from the goal is this. He said, in any value stream, whether it's in plant flow operations or DevOps, right, you have a flow of work, right? There's a direction to the flow, and there's one and only one bottleneck. And he said, any improvement not made at the bottleneck is an illusion. And here was his logical proof point. He said, if you improve something after the bottleneck, it will always remain starved for work waiting for the bottleneck. And if you improve something before the bottleneck, it will just pile up at the bottleneck, right? So thus the importance of knowing where the bottleneck is. And so what our observation is that here's typically how the bottleneck moves. In the beginning, it's around environment creation, right? It's like when someone wants an environment, they can't wait 52 weeks to get one, right? Right? We need to create one on demand, right? And that's how we get the fast flow. So after we break that bottleneck, kind of where does it move to next? In general, is the code deployment process, right? You can't get the fast flow if each deployment takes 6 weeks, 1,300 steps, and 400 people to actually successfully execute. The countermeasure obviously is automate the code deployment process. And then where next? In general, is test, setup, and run. Right? We can't get the fast flow if it takes us 2 weeks to create the test environment and the test data sets, and then 4 weeks to actually run it, right? Especially if there's a lot of manual testing. So the countermeasure is not only automation of the test process, but probably also massive parallelization of testing, right? So that the test rate can keep up with the development rate. Then the fourth bottleneck typically then becomes architecture, right? We can't get the fast flow if every time we want to make a change to the big monolithic architecture at Sun, we call it the BWAS, the big wad of crap, right? You know, in order to, everyone's so afraid of those changes, right? Because everything's so tightly coupled that to make the change, you have to spend all your time in committee meetings trying to get permission from 35 people all to say it's okay to make the change, right? So the countermeasure is, you know, the microservices or service-oriented architectures where things can be contained so that local changes can't cause global failures, right? And so once you're there, then the bottleneck typically becomes development and product owners. In other words, how many good ideas can we come up with that are actually worth testing with real-life customers? And I think one of my observations has been, you know, if you look at the unicorns, there's this language they use. If you listen to Diana's talks, right, or whether it's Netflix or whatever, it's like there's this, they use language like, we want to increase developer productivity. We want to make sure that they can get work done, right, whether it's cognitive environments or whatever. And I think that's where the bottleneck should be, right? Whether you're in dev, test, or ops, or even information security, our goal is to keep developers productive, and I think that kind of creates a narrative for why the bottleneck moves like this. And just to share with you oh, here's a cool story. So just to kind of share with you, and so Jez Humble would say, what is a good metric for developer productivity? In his mind, the best proxy measure we have is lead time, right? How quickly can we go from code commit through test through deployment and operations? Why? Because developers need fast feedback on their work. In other words, in a system of work where lead time is measured in 9 months, the only time that the developer realizes they've done something wrong is 9 months later, and we can no longer trace the cause and effect. And just to share with you, like how relentlessly you know, high performers try to tighten up those feedback loops, consider this case study from Elizabeth Hendrickson, who helped pioneer the whole notion of automated testing, you know, 15 years ago. She said she's now director of quality engineering at Pivotal Labs for Cloud Foundry inside of Pivotal Labs. And she said, oh gosh, I need stronger bifocals. I got to make this bigger. She said the biggest problem she observed was that it took for a developer to get feedback on their work, it would require spinning up 45 virtual machines that took a half hour. And that was so painful and so long that they would never do it. So the only time they would get feedback on their work was during a production deploy. So they actually created this project using Warden, you know, like Docker, to basically make sure that you can recreate the entire test production-like environment inside of a set of containers that you can actually run on every developer laptop, and that you can actually get that running now in 6 minutes, right? And so now, as a part of developers' daily work, they're getting constant feedback on their work, right? And so I think this is like one of these technology miracles that was just not possible 10 years ago and allows a whole dimension of productivity that, you know, was out there before. All right, so what are some of the predictors of performance? What we found in the benchmarking is one of the top predictors of performance was whether ops used version control. In fact, this was actually one of the top predictors of mean time to repair, deployment frequency, and lead time. And by the way, whether ops used version control was a higher predictor of performance than whether dev used version control. Can anyone speculate on how or why that could be true? I mean, it's insane, right? Any theories? Back out? Okay, certainly one of them. You have to be able to roll back to some known good state. Yep. Audit trail, yep. Single source of truth that spans the entire value stream. Yeah, that's probably a really important one. Yeah, here's my favorite theory. And that creates accountability and trust. I love this example. If you count the number of configurable settings, there are far more configurable settings in the environment than in the code, right? And I think anyone who's done like a production ERP code migration, yeah, I think can resonate with this, right? When a code migration fails inside of Oracle Financials or whatever, when it fails from dev to test and test to prod, in general, it's almost due to an environment failure. There's something different in the environment, right, that wasn't properly trained. And so it means that of all the things that need to be checked into version control, it's actually the environment more so than the code. So there's also continuous integration practices, automated testing. And so the outcomes are that, not only do we have a shared repo for dev, test, and ops, we have determinism in the release process. We have consistent dev and test environments and product environments all synchronized long before the big deployment and release. We are freeing ourselves from this learned behavior that deployments hurt. And this is what shrinks lead time. This is how we go from lead time measured in months down to weeks, down to days, to ideally on demand. And then when we shrink lead time, that's how we can actually increase deployment frequency and replicate the outcomes that the unicorns have gotten. So the first way is all about left to right flow of work. The second way is all about the reciprocal, so the right to left flow of feedback from ops back into dev. So in other words, whenever there's a service impairment, service outage, security breach, compliance failure, how do we feed that to the earliest stages of the dev lifecycle so that we can prevent it from happening? And if we can't prevent it, how do we at least enable quicker detection and recovery? And so I think the heart of every process improvement methodology is this notion of shortening and amplifying feedback loops, right? And in my mind, there is the paragon of that principle is this. It's the Toyota andon cord. So I spent a week at the University of Michigan getting trained in the Toyota production process, and at the plant floor, I was startled to find that plants modeled after the Toyota production system, it really is true. They have this thing on top of every work center called the andon cord, and everybody is trained that when something goes wrong, you pull the cord. Everywhere from the regional vice president to the plant manager to the work center supervisor to everyone on the plant floor, they know that if the parts are defective, you pull the cord. If the parts aren't there, pull the cord. If the work takes longer than documented, say it takes 1:20 versus 50 seconds, you pull the cord. What happens when you pull the cord? The entire assembly line stops. Trucks stop coming out the other end. So among my learned colleagues here, can anyone speculate or hypothesize how many times is the andon cord pulled per day in a typical Toyota plant? Order of magnitude? 100. Higher. Yeah. 3,500 times a day. And so you can imagine when I first read that, my reaction was this. These guys are morons, right? What sort of idiots would pull the cord 3,500 times a day? They probably don't know that whenever they pull the cord, it's going to stop the entire assembly plant. That local failure is going to cause a global disruption. So the amazing thing is when you ask, why do you pull the cord so often? Regardless of where they are in the plant, their answer is almost the same. It's this. It's the only way that we can sustain a build tempo of 2,000 vehicles per day. So that's essentially one completed vehicle every 55 seconds. So essentially what they are verbalizing in this answer is that if we don't pull the andon cord, we're going to allow technical debt to accrue downstream where it becomes far more difficult, far more expensive, maybe even impossible to fix, right? And I think just to kind of evidence frame this statistic is about 10 years old. These days, in an average Toyota plant with about the same amount of square footage, same amount of capital equipment, same amount of labor, they now build 4,000 vehicles per day, just showing how the best always get better. So I think the equivalent of Toyota in the DevOps space is Google. By the way, I have this incredible sense of anxiety that, Diana's sitting in the room, I'm like, oh, please let this be right. So back in, 2 years ago, they had approximately 15,000 engineers, that's dev, test, and ops, SCM, and so forth. It's working on 4,000 simultaneous projects. And just as a mental benchmark, HSBC, a large European bank, they have about 18,000 engineers spanning dev, test, and ops, so more engineers than Google had at the time, but they're probably working on an order of magnitude fewer projects. Google has all code checked into one common source code repo. They were doing 5,500 code commits per day, each one resulting in a production deploy, and they're running 75 million test cases daily. And of course, it doesn't hurt that they have more servers than God does. But the real question is, why would they run 75 million test cases, let alone write 75 million test cases? And I think the answer is framed, again, so poetically, right, by Aaron Massari, who's in the SCM group at Google. And he said, it is only through automated testing that can transform fear into boredom. And he said, imagine the paralyzing amount of fear you have as a new dev, test, or ops engineer at Google, where you know that any code commit you make, any commit you make, could take down every Google property all at the same time, right, which apparently does happen. He said the only way that you can get people productive, right, out of that fear is to know that there's a safety net underneath them that will catch errors long before it gets into production. And I think this is one of the hallmarks we see in every high performer is that, in whether it's Facebook, Etsy, Rally software, new engineers are required to do a deploy in the first week, often the first day. Etsy, they're required to do a deploy on the first day. And I think what's interesting is this, right? Suppose you had a junior engineer, deploy a change to Etsy.com, and it actually took down the entire site. They wouldn't fire that engineer, right? Instead, I think I think this would be the reaction. Huh? Haven't seen that one before. Clearly, we need one more automated test in the deployment pipeline to prevent that happening in the future, right? And they all view it as a way to be productive. So here's another pattern. Developers carry pagers. I love this quote from Patrick Lightbody. He's now VP of Product Management at New Relic. He said, "We found that when we woke up developers at 2 a.m., defects got fixed faster than ever." And he said, I don't think he hated developers. It's not like he was waking up random developers at random times. I think what he was putting his finger on was that in order to have genuinely shared goals between the dev, test, and ops value stream, you have to have some extent of shared pain. And so Werner Vogel's says even more succinctly, if you help build it, you must help run it. So in the spirit of empathy, a big DevOps value, just like in the ops community, I think there's a lot of fear that DevOps is going to automate everyone's jobs away, and I think it's impossible to overstate how important that is, right? When we fear for our livelihoods and our ability to care for the dependents around us, that's important. And I think there's something similar here that evokes the same sort of fear in developers, right? When you see that DevOps person coming down the hallway, run the other way, and better yet, let's sabotage the effort, right? Let's make this DevOps thing go away. And I think the reason is that we did not become developers to wear a pager. That's for the ops underclass, right? But I would submit to you there's actually an alternate narrative to that. And that comes from Tim Tischler. He's the director of ops engineering at Nike. And he said, as a career-long developer, there's never been a more satisfying point in my career than when I got to write the code, push it into production myself, get to see the happy, smiling faces of my customers when it worked, get to see their angry, shaking fists when it didn't work, and when I could fix it myself. I didn't have to open up a ticket and have someone fix it in like a day when I could have done it faster and maybe even better myself, right? And I think that sense of joy, serenity, and flow, in dev work has, in many places disappeared over the last 10 years, right? Just because it becomes so much harder. I think DevOps actually helps recreate and bring back some of that joy of doing work. So I love this quote. So how important is LISA to DevOps? Well, hey, here's Tom Limoncelli presenting at USENIX New York, and he was describing another set of patterns that that you see inside of Google. That there's this apparently long-standing. Well, there are many surprising practices at Google, but one of the ones that surprised me the most was this long-standing tradition that all services before they're taken over by the site reliability engineers must be self-managed by devs for at least 6 months. In other words, before you even earn the right to ask someone else to manage your code, you have to manage your code, right? And so there's something called the HRR, the hands-off readiness review. Tom, where are you? Of course you're right on. But I met Tom finally in person at the DevOps meetup in New York, and I show the slide and everyone laughs. I'm like, I didn't say anything funny. What's so funny? Tom was in the audience. I was like, awesome, thank you. But one of the things I just love the most, just to show the cultural respect between dev and ops, the mutual accountability and respect between dev and ops is what happens when something goes into production. Site reliability engineer takes over the custodianship and service level responsibilities of the operation. What happens when it goes fragile, right? Because Murphy does exist. There's something called the handback, right? Where essentially, apparently it's like, it's like your service is destined for great things, your puppy is cute, but we keep being woken up at 3 a.m. having to clean up after it. Here's your puppy back. You're going to go back into a self-managed state. And the reason why we do this is so that we have enough cycles to help you make this thing production ready, right? We will help you as a consultant, as fellow engineers, right? And we can't do that if we're being woken up at 3 a.m. every day. And I think the reason why this pattern is important is that without this escape valve, operations become stuck and doomed to be drowning in unplanned work. How many people of you here at some point of your career, or how many people here have a friend at some point in their career would have loved a handback clause? Absolutely. All right, so here's another, so that's an extreme form of feedback. Here's a more pervasive form of feedback. This is the famous John Allspaw, Michael Rembetzi's boss, who's going to be on the panel right after me, right? So the reason why I show this picture is not to show his, barely smiling face, but what's behind him. So Etsy's gone on record, right, saying that they're generating something, this was about 3 years ago, they're generating 200,000 production metrics every day, tracking those. So features, application health, database health, storage, networking, virtualization, everything. And there's this culture that developed at Etsy where they said if a feature is important enough to implement, it's important enough to create production telemetry around, to see how it's actually doing in production. And it shouldn't have to feel for the developer like doing a database schema change, right? It has to be done as a part of their normal work. And that, I think, explains why they invested so much effort into the StatsD and Graphite libraries, where a developer can write one line of code, and then bang, you get your 250 and thousandth and first metric. So in this case, it's the number of logins, successful and unsuccessful, and overlaid onto each one of those graphs is a vertical line. Each vertical line represents a deploy, because now, just like 10 years ago, one of the major causes of issues, 80% of the time when something goes wrong, is due to a change. So let's put that onto the production metrics. And so what's amazing about DevOps organizations is that no developer will do a deploy and go home without first checking to make sure that their metric hasn't been flatlined, or better yet, everybody else's metric hasn't been flatlined. And this is one of the cultural hallmarks we see in every DevOps organization. This is Rally Software, publicly traded Agile planning software. This is Tarun Reddy. He was the director of operations, site ops. He's now the VP of site ops. And you can sort of see the same cultural artifacts, the panes of glass. They actually feed all their production metrics into Tableau, that amazing company here in Seattle where it's like SPSS makes it look so ancient like it is. What's amazing about Rally Software Ops is inside their ops team, they have a statistician need to be written, right, in order to help other groups, find variance, even earlier, right? And so right before I took this picture, someone had whispered into Tarun Reddy's ear, Tarun, the dilithium crystals are fluctuating. We're down 30%, right? And everyone's looking at these graphs, trying to figure out, is it a storage issue or a database issue? And I actually asked a question that I think genuinely angered them. I was like, are we actually, is like a 7 outage happening right now? Are customers actually down? And they're like, no. no, we just found this variance that we want to understand before causing an even larger variance that could affect our customers. So why do I think this is important? As someone who comes from the security background, the fact that people actually look at their logs is astonishing and so amazing. Studies have shown for now 5 years running, the PCI Verizon data breach studies, year after year, the mean time to detect cardholder data breaches is measured in quarters. Right? In other words, how long did it take the organization to actually find out they're leaking cardholder data? Months or quarters. Why? No one's looking at the log files. Right? And by the way, how did they find out? Because a customer or a business partner said, hey, your fraud levels are just increased by an order of magnitude. Right? So, how amazing is it in DevOps organization? Not only are they looking at the log files, but they're scrutinizing it all the time. So there's actually something else I want to mention here for this group. So I actually asked them a question. I was like, what's our ticketing system to use? I'm just curious. And they looked embarrassed. They said, we don't have one. Like, my respect for them went from like here to like here. I'm like, what do you mean you don't have a ticketing system? You don't write down things you need to do? Right? And it took me a couple weeks to realize what they do is actually in some ways much, much better, right? Their ticketing system is the Agile planning, is their own tool, right? In other words, their work is right alongside the dev work, right? Whenever they have an incident, that's a card that's being worked on, right? When the technical debt issues arise, those live just right alongside the dev features, right? So it's actually far better to have dev and ops work living in one pool, right? So they can properly prioritize on a global perspective than it is to have them living in 2 different places. All right. One of my favorite sayings is this: you're only as smart as the average of the top 5 people you hang out with. There's a very unfortunate corollary, which is when you hang around smart people, you feel dumb all the time. And so trust me, I feel dumb a lot. And so one of the dumbest I've ever felt was when I was on a Skype call with Jez Humble and John Allspaw. And what we were talking about was the Knight Capital failure, or as John Allspaw likes to call it, the Knight Capital accident. And for those of you who aren't familiar with it, that was a 15-minute deployment error that caused a $440 million trading loss, which actually forced the company to be sold over the weekend, lest it create systemic risk to the entire financial system again. And what we were talking about, and essentially in the course of 90 minutes, Allspaw and Jez convinced me and made me question some of my most deeply held beliefs that put me on the brink of what I can only call a 6-week period of existential despair. So let me share with you what they convinced me of and why I found it so troubling. So when we were talking about the night capital accident, and there are two dominant narratives of why it happened. The first is that it was due to a change control failure. In other words, and I think that's valid. In other words, if we had better change control processes, right, we could have maybe spotted the risk earlier, prevented it from going into production. And if we couldn't have prevented it, at least we could have enabled better, readiness, detection, and recovery. So I think that's valid. The other dominant narrative is that it was due to a testing failure. In other words, with better testing processes or better testing, we could have caught the error earlier. And if we couldn't have caught it, then we put problem bypass procedures in so we could enable quicker detection and recovery. The problem is this. The typical low trust command and control countermeasures that we put into place by tradition over the last many decades almost certainly preordains the future likelihood of this happening again and it being worse. And so here's how they proved it to me. What is a typical countermeasure that we put into place when you have a change control failure? In general, it's add another field to the change request form and add one more level of signing authority required, of approval required to put the change into production. Does that resonate with you guys? The problem is, we know through about 100 years of research that the greater the distance between the person doing the work and the person deciding to do the work, the longer that distance, the worse the outcomes, right? And especially in highly complex work, the only person who can decide how to do the work, when to do the work, and whether to do the work is actually the person doing the work. And so the more distance you have between the two, the worse the outcomes. It's like, uh-oh. It's like, this is bad, but maybe not as bad as the second argument. What happens when we have a testing failure? In general, the countermeasure is do more testing. And if there's any manual testing involved, doing more testing almost certainly means deploying less often. And I just showed you the CSG graph that says the longer the interval between deployments, the lower the change success rate, and the higher the mean time to repair. So my reaction, after this conversation was like, oh no. Like, ah! It's like everything that I believed in for the last 10 years is wrong. What is the right countermeasure? We need to deploy more frequently and fully empower the person who's doing the work to decide how and when and whether to do the work. Right? And we even found evidence of the need for this in the benchmarking. So this is called the Westrum organizational typology model. Dr. Westrum found that this is one of the top predictors of patient safety in healthcare organizations. And the third top predictor of organizational performance and IT performance was how organizations answer this question, revealing whether they're low trust or high trust. Low trust organizations shoot messengers who tell bad news. We shirk responsibilities. We discourage bridging between teams, whether we're dev, test, or ops. We cover up failures. Why? Because messengers of bad news are shot. Whereas high trust organizations, we actively seek information. We train messengers on how to tell bad news. We have blameless postmortems. We share responsibilities and outcomes, and that means bridging between teams. And when failures happen, it causes genuine inquiry. And they are open to novel, crazy ideas. Why? Because for genuinely complex problems, it probably requires very novel things. If it were obvious, it would have been solved already. So how organizations answered this question was one of the top predictors of change success rate, mean time to repair, deployment frequency and lead time, and organizational performance as well. And I think how we go from low trust to high trust organizations is probably the grandest management challenge of our decade. Because many of us come from organizations that we have a century-long tradition of command and control, low trust bureaucracies. And just to evidence kind of why I think this is so challenging, consider how the proposal, the countermeasure of doing deployments more frequently is going to be heard by senior management. I think it's going to be heard like this. Let me get this right. You've screwed us before in the past, and now you want to do it more often with less supervision. I never want to hear that again, ever. Just close the door on your way out. And yet, the science does say that in order to get from here to there, it requires high trust management styles. So to reveal the other top indicators of predictors of performance, we rely not on change approval processes, but instead we rely on peer review, right? It's not authorization, as Allspot would say. It's all about peer review. It's about high trust cultures, proactive monitoring in the production environment, and those things apparently create a sense of a win-win relationship between dev and test and ops, and even information security most likely. So by doing this, defect security issues are being fixed faster than ever. We have small disciplined testing teams that allow us to create deployment pipelines that allow us to safely migrate code into production and environment changes. All groups are not only communicating and coordinating better, but everyone's getting more work done. So let's go to the last set of principles. The first way is about flow as you go from left to right. The second way is about the right to left flow of feedback. And then the third way is all about this creating a culture of genuine experimentation and learning, which obviously encompasses high trust. My belief is the best embodiment of this principle comes from Adrian Cockcroft, who is famous for many things. Most recently, he's most famous for his contribution at Netflix as cloud architect. By the way, Adrian Cockcroft, this is a guy who's changed my life. He was a distinguished engineer at Sun Microsystems. He was the third distinguished engineer at Sun Microsystems who didn't come through the engineering ranks, the dev ranks rather. He helped change eBay and get them back on their feet, and so he's changed my life from afar. But he says, our goal is to do painful things more frequently so that we can make it less painful in the future. And even though we make life hell for developers sometimes, the reaction that we get back from dev is, thank you. Thank you so much, because we know doing this will make our lives less painful in the future. And he's actually channeling Mike Nygaard, who wrote the amazing book, Release It. And so I think the best evidence of the effectiveness and efficacy of this philosophy and practice was the first Amazon EC2 outage that happened in 2011. And for any of you who were using EC2 at the time, you will remember this because you went down. And so every Amazon customer went down, except for one, Netflix. And so for weeks, everybody was asking, what is Netflix doing differently that caused such a different outcome for them? And the leading theory was, well, it's obvious, right? Netflix is Amazon's biggest customer. They must have a special feature, a special flag they use that says, don't crash, right? The real answer was revealed, some weeks later when they put out this seminal blog post, where essentially they revealed two engineering design decisions they made very early on. The first was, we can never depend on Amazon for availability. They will never be there when we need them most. Two, as a consequence, in order to survive failure, we have to fail all the time. And that's when they unveiled, the famous audacious thing called Chaos Monkey, this incredibly audacious thing that runs in the cloud, right? And on every production server, they have this thing that randomly kills processes and entire compute instances in production. And you can imagine, very soon after, they quickly got more resilient code, more resilient environments, and a more resilient organization. So here's two things that Adrian Cockcroft doesn't tell you, but I will share with you. One is, before you deploy Chaos Monkey in production, first run it in test, which they do. Second is, did you know, on that day of the first global EC2 failure, they went 5 hours into the outage, into EC2 outage, without declaring a Sev1 incident. Every hour, they would revisit and say, should we declare a Sev1 incident? And they would decide, no, it will probably come back. Only after 5 hours did they make the decision, maybe it won't come back. Maybe we should activate some business continuity procedures just in case if it doesn't. And the reason why I think this is so amazing is that in a sea of such utter chaos and madness, right? Netflix was one of the few islands of serenity, right? Where they were able to ride this out, and I think that's the payoff of what happens when you directly do large-scale fault injection into the production environment. And I think a more contemporary evidence point of this happened just very recently, during the big AWS reboot that happened 6 weeks ago. This comes from Christos Kalantzis. This is the first time actually I said his name. He said, when we read the news about the emergency EC2 reboots, our jaws dropped. When we got the list of how many Cassandra nodes would be affected, I felt ill. But then I remembered we ran Chaos Monkey. So their reaction was to bring it on, right? And the results stunned me. Of the 2,700 Cassandra instances in production, 218 were rebooted and 22 didn't even reboot. And yet, no downtime was experienced by the customer. So, I think that is utterly amazing. So I have one last technical practice I want to share with you, and in some ways I think this is the most important, is this need to allocate 20% of all cycles to reducing technical debt. So the person who recommends this is a gentleman named Marty Kagan. He's a hero in the product management space. He was VP of product management at eBay in the early 2000s, in the same era that Adrian Cockcroft was there. He wrote an amazing book called Inspired, which modeled how we did product management at Tripwire. And essentially what he's saying is, when you are a product owner or a product manager, the first thing you must do is take 20% of all the dev cycles, and let's extend it to ops cycles as well, because ops are engineers too, because those 20% are not for you being the product manager. They're for the ops and dev people to use however they best see fit, to fix problem areas of the code, problem areas in the environment, to use however they best see fit. And so, why would anyone believe him? It's because when he was head of product management at eBay, right, when they were having chronic site down issues, he said the outcome of that was that if you don't spend your 20% tax paying down technical debt, the preordained outcome is that you will spend 100% of your time paying down technical debt. He said, imagine what it's like to tell all your friends, colleagues, and peers that you haven't shipped a new feature in 2 years. That is what happens when you don't actively pay down technical debt. And so when you can create the coalition of the willing, your fellow travelers that want to fix these problems, right? That's how you make an amazing difference, and that's where the cycles to do these DevOps transformations come from. There's actually a more contemporary example that I think is amazing. LinkedIn, months after they went public, had a 1 quarter long change freeze. So despite all the promises they made to the public markets, they said all bets are off. Why? Because it has become so dangerous to deploy code that we cannot do deployments any longer. And I just think about the bravery it took to do that, and that's called Operation Inversion. And by the way, this story has special significance to me because I've been a long-time observer of LinkedIn. Hal Pomerantz and I, another long-time friend of Lisa and Sands, we used to, around 2008, 2009, we would watch LinkedIn go into their maintenance windows on Friday night, where it would say, search is not working, right? We'll be back Saturday morning. Right, we'll be back in 4 hours. Right. They, for years, right, they would never, much of the site functionality wouldn't come up well into Sunday, right? And so I remember around this time, LinkedIn started to look different, right? They had the different pages, elements, rendering independently, just like Amazon, right? And apparently the reason was Operation Inversion. They worked on refactoring the deployment processes, they standardized environments, they decoupled their architecture, and that was all made possible through this. And I think the lesson here is, it is so much better just to take 20% off the table every day as a part of our daily work, right, than it is to have to do something so disruptive as declaring to the public markets that you can't ship features anymore. And by doing that, that's how we go from a situation that looks like this, that we know invariably turns into a situation that looks like this, and that's what we get to hear, right? This is the cage from the VeriSign DNS.com infrastructure, one of the single points of failure for a good chunk of the internet. This is probably a $60,000 cabling job, which they didn't even blink at, right? It's like, this is what we just needed to run a genuinely mission-critical service. So why do I think this is important? This downward spiral happens everywhere. Independent of company size, independent of industry vertical, profit, not for profit, left unchecked, we as ops practitioners, our fellow dev practitioners, left unchecked creates hopelessness and despair, right? We damage fellow human beings, and ultimately none of us can achieve our goals, and ultimately we fail the organization that we serve. So there's an important human factor for this mission to me. But another element is economic. A fellow co-author and I, we did a calculation. Just how much business value is there on the table? for us to recapture. If we could just have the amount of waste in the IT value stream and redeploy it in a way where we can get 5 times the value back. And the number that we came up with was $2.6 trillion per year. Just to calibrate, that's about the same as France, the 3rd largest global economy. So here's the way I think about that number. It's through the eyes of my kids. I have a 6-year-old and 2 identical twin 4-year-olds. You put $2.6 trillion back into the economy over 20 years, you make a radical difference and a material difference to the level of productivity, standard of living, right? And ultimately, you get to earn the right to affect the big things in life, right? The level of health, wealth, and prosperity, right? If you want to tackle big problems like global climate change, we will only do this by injecting, creating value like this. So I think it's an important problem. Our mission is to positively influence the lives of 1 million IT professionals by 2017. And I think so that's one of the reasons why my area of passion right now is not studying the unicorns. Yeah, the unicorns are fine. Google, Amazon, they have Dyna, right? They just do what Dyna says. They're fine. I think what we are watching now is the mobilization of the horses, right? That's where 99% of the technology work is happening. So the goal is how do we elevate the state of the practice where most of the work is happening? That was the reason why I helped host the DevOps Enterprise Summit a couple weeks ago, where we had some of the largest, most complex organizations sharing how they too were adopting DevOps principles and patterns and getting the same sort of outcomes that we would expect to see out of Google, Amazon, Etsy, and so forth. So if you're interested in any of this, just send me an email. I'll send you this. I'll send you a copy of this presentation. There's a link to get a free excerpt of the Phoenix project, the videos and slides from the DevOps Enterprise Summit, my recommended reading list, and if you're interested in seeing the early drafts of the DevOps Cookbook, which is about 2 years late, but it will get done. And by the way, don't take a picture of this. Just pick up your phone and send an email to realgenekim@sendyourslides.com, and the subject line just put Lisa, and you'll instantly, or almost instantly, get an email with these links. So anyway, so oh yeah, phone or laptop, realgenekim@sendyourslides.com, subject line Lisa. So with that, that concludes the prepared part of this presentation. Thank you so much. I'm genuinely grateful to be here. Thank you. Any questions? Comments? Uh-oh. Oh, actually, then, in the absence of any questions, can I just tell a quick story? Oh, yeah. Oh, thank goodness. Yeah.
Might hurt, Jim. Gene, it hurts. Thank you for coming here. Hey, so I really enjoy learning from other people's mistakes rather than making my own, which I do plenty of anyway. So I like reading postmortems and learning about things like the Night Capitol accident, as John refers to it. Since we don't have the equivalent of an NTSB in IT operations, what kind of things can we do to encourage people to report on what they do, on their postmortem procedures, on their postmortem findings? How do we improve the sharing of information?
Yeah, great question. And let me ask you, I can answer in an oblique way and then a concrete way. I was talking with a guy who helped headed up the Verizon PCI data breach studies. And when we finally met, he was like, gosh, the whole benchmarking work that you guys have done, that's so awesome, because what they do is they're like the NTSB, the National Transportation Safety Board. Whenever there's an airline crash, they're trying to pick through the wreckage, trying to figure out what happened. He said, how much better is it to actually look at the planes that actually didn't crash? Right? Because there are the clues of what enables greatness, right? And so I think the combination of the failures or the accidents and the study of the high performers that allow us to sort of frame a narrative of what works and what doesn't work. So I'll say I have two responses. I think the folks at Etsy and the other unicorns, Netflix, they did this great job of just being so transparent about failures and having these wonderful, postpartum, blameless postmortems, that are just so fun to read. So I think that's an element. And so I think there's a social pressure, that says, hey, if you are a great ops practitioner, that's what you do. I love that. But I think there's a second element, which is why I'm so excited about the work that we've been doing with Jez Hummel and Nicole around the benchmarking work. And so we're actually, within weeks, going to be readying the next stage of the survey analysis, survey design for the third year of the State of DevOps. And if you're interested in helping give input to that, we have a Google Plus community page. So just send an email to that thing, Realgene Kim, and send your slides. If you do a reply to that email, it will come directly to me. And I can send you the Google Plus link where you can help us during the project. And then if it's like last year, we'll probably launch sometime at the end of the year. And then we just need respondents, and then we need help analyzing. Thank you. Yeah.
Hi. Thanks for your talk. Very interesting. You outline a lot of practices that really resonate with me, and I'm new to a job where all of this is really relevant. And in particular, you mentioned the Puppet Lab State of DevOps survey. You draw a lot of really strong conclusions, quantitative conclusions about companies that do better, why they do better, how much they do better. It's a really important data set. Maybe you've already done this, and if so, I'd love to see where it is. But I would really like to see that data set and the methodology you use published in some suitably anonymized form so that other people can replicate the findings that you have.
Yeah, totally. I think our vision is eventually to do that. The question is, hey, open source all of it. And I think we'd love to, but we want Nicole to have tenure. There's certain privacy protocols that we have to follow. But yeah, so email me. Reply, I'll send you a Google Plus link, and I want you to get that into the community page, and we can add to the backlog. I mean, just rest assured, we'd like to do the same thing eventually.
Thank you.
After Nicole gets tenure. Yeah.
How do you deal with, or how do organizations using DevOps deal with regulatory issues involving separation of duties, where they say, thou shalt not mix your developers and your production systems?
It was interesting. So at the DevOps Enterprise Summit, I had every speaker, of the 50 speakers, I had them all. The last slide I wanted to essentially have this title. Here's what I don't know how to do, or here's what I'm looking for help on. And so the reason why that's so important to me is, right, that can help frame a research agenda. And so the top three were, number one was, I don't know how to do automated testing for large, complex legacy apps. Two was security and compliance. We want to do this, but those bastards in security won't let us. And the third was, how do we get approval from management to go even faster? I've been working with a group of colleagues. We've been working on something called the DevOps the DevOps Audit Defense Toolkit. And what it really is DevOps is all about boundary spanning. So I think it's a way to say, all right, if we can't bring DevOps to the audit community, let's bring auditors into the DevOps community. So let's train ourselves in how we actually go through a top-down risk-based process to be able to make the argument from here's the business objectives, here's the risks, here's the technical things that could cause that risk, here are the control objectives, the controls, here are the evidence and controls. And so the Phoenix project, we actually took the Phoenix project, Parts Unlimited, and we said, we're their auditors. And we actually wrote an audit narrative for their order entry and e-commerce properties that apparently are regulated by SOX, HIPAA, and FedRAMP. And actually went through, and I think the goal is to actually show, hey, we understand the objectives, we understand the risks, and if you count the number of controls and compare that against a standard sort of SDLC thing, there's probably 2 orders of magnitude more controls that are operating all the time, and here's where they are, and here's how you count them. And you can get all the evidence on demand from Jenkins, from Puppet, from Chef, from whatever.
The main concern is PCI.
Yeah. Oh, so is Rembetsi here? I got to spend a. Yeah, so PCI is unlike many other compliance regimes because it's so prescriptive and it's at the technical practice level. But there is a set of arguments you can bring to bear that say, talk about the alter control procedures and so forth. And I got to spend a half day at a unicorn organization, and they chose a very literal interpretation of PCI. And this is for their payment gateway team. And the dev manager there said, there is a level of ghettoification that is happening in our team that's not happening anywhere else, right? Because no one's allowed to be able to be a full stack engineer and so forth. And the reason why I think that's so interesting is that here's a high trust team with a shared experience with the rest of the unicorn groups, but you make them act in a low trust toolkit way, suddenly they have behaviors that look like a low performer. I think that's that's astonishing and important. So I think the prescription would be my friend Brandon Williams. He helped build the PCI practice at VeriSign. I introduced him to them, and his advice was, my response was like, I don't know. But Brandon might have some ideas. And he said, the discussion really is you need to have a discussion not with the PCI assessor, but with the acquiring bank, right? Because you need to talk to the compliance manager there and begin a discussion of, hey, objectives, risks, technical practices, and that is how you have that discussion of how to make it so. Sorry for the long answer. And if you email me, and I'll send you a link to the DevOps Audit Defense Toolkit.
Earlier on in the talk, you had some statistics. If I understood them correctly, you're increasing, well, these organizations increased their rate of deployments up by at least an order of magnitude, but the rate of failure per deployment was halved. Now, that still leaves you with around about 5 times more failures per unit of time.
Yes.
Presumably there's something better about these failures than you would have had otherwise.
Yes, let me repeat that incredible observation. To paraphrase, you said high performers are deploying 30 times more frequently, but they only have 1/2 the change failure rate. In other words, they're making 15 times more incidents and errors or outages, of which Roy Rappaport at Netflix says, yes, that is true. High performers fail more often, right? And that's part of the high trust culture. And he actually sent me a very long email saying, we had an incident, or maybe his friend had an incident where this person, caused a customer-affecting outage, and the discussion, and he said to me this: did we ever think about firing this person? And he said, absolutely not. This is like he is doing what needs to be done in order, and we trust him. And so I think a part of high performers is, yes, they actually have more errors, but they have a much shorter mean time to repair, and ideally long before the customer is impacted. Yeah. One more question, and then I'll turn it back over to Nicole. Yeah.
Yeah, I was just wondering, I work for a county government, and we have like 9 lines of business, and so I was wondering if you've done much research on how what you're talking about here lines up with county government when we can't. I don't really want to add like the 15th way we manage things because all the vendor requirements. So I'd love to hear what you have to say.
One of the keynote speakers at the DevOps Enterprise Summit was a gentleman named Mark Schwartz. He's a CIO of the U.S. Department of Homeland Security, Citizenship and Immigration Services. And if you're interested, I can introduce you to him. But he gave a great talk. It was actually probably one of the most popular talks at the conference. And one of his thesis points was that the bureaucracy is not this nameless, humanless people who whose jobs it is to make sure everyone doesn't get work done. Instead, you find that they were actually genuine human beings who were trying to do the right thing. It's just comes down to defining what the right thing is. So, and if you do that, you'll get a link to the YouTube channel where we post all the videos, and it's Mark Schwartz, Department of Homeland Security. So actually, can I just share with you one story before I turn it back over to Nicole? So Tom, you should use the send your slides thing. Brandon Williams, the PCI guy, wrote this. So it's 2 weeks ago. It was right before PuppetConf, right? They found out that they want to talk I had 3 days notice, right? It's 20 minutes before the talk, and I'm configuring this, and I'm getting MailChimp API security errors. Like, Brandon. It's like, help. It's not working, right? We're working this thing for 20 minutes, and I'm trying to work on my talk, right? And I'm like, Brandon, I can't work on this anymore. Can you please take care of it? Because I go on in 20 minutes. Because I've got your back. Like any ops practitioner, right? That's what we want to hear. It's like, don't worry, I've got you covered. And it worked. I found out about 4 hours later that when he said, Gene, I've got you covered, he was on an airplane. He was manually debugging something in Heroku, right, on an airplane. And had I known that he was on an airplane, I think I would have freaked out. But anyway, ops story and dev story. Anyway, thank you so much. I'll be around all day.